Hello, welcome to today's interview question for designing a data warehouse. Um, Today we're going to take up this question that came up in the AWS interview questions. So this is to take an app like Tinder and try to design a data warehouse for their business use case. And this is going to be an interview question, so we'll probably simplify the um, requirements a little bit. We'll think about what we can do within the next 20 minutes and trying to collaborate with the interviewer. If the interviewer takes a different direction, stopping and turning towards a direction that all might be needed during the interview. Given all that, we'll try to design something which is simple but is able to support the needs of a dating app like Tinder. Let's uh, recap and let's check what the steps are and what kind of iterations we'll have to do while designing a data warehouse. When we start designing a data warehouse, the first thing we should do is to look at the business need and come up with a tentative list of entities and relationships. At this point, it's better to check with the interviewer if you're going in the right direction, checking if you are getting all the entities that they want to cover. Probably they are talking about certain use cases. Probably they want to go into different use cases. They want to simplify certain use cases and not have all the functionality that the app typically has. So check with the interview at this point. Then we're going to check the business scenarios, walk through uh, a user login, a user check-in, how the user gets benefit out of it, what functionality the app or uh, the application itself does, and see if the entities and relationships we have listed cover all that. If needed, adjust it, talk to the interviewer to make sure whatever you're adjusting makes sense. The next or the most important piece of going towards the data warehouse is to understand what kind of business need would be there, what kind of questions would the business ask, um, would the would the business want to understand how much sales is going to grow over the next 12 months. Probably for an app, um, probably they might also want to use different metrics like how many people are using it, is the usage growing, um, are we able to um, like complete functionality that we intended to complete. So those may be other questions that uh, the business might want to answers to, like list out those questions, at least the most common ones, so that we can solve uh, the data warehouse for that those particular questions. With those questions in mind, see what kind of dimensional model you need um, based on the question. And essentially, when we model a dimensional model, we'll see what are the questions uh, the business is asking and what measures are there in those um, questions that would determine what kind of fact tables we need and what kind of dimension tables we need would be around those fact tables. You can decide that next. At this point, um, you may end up completing your 20 minutes. That might mean the interviewer might want to go on to another topic, or they might still want to check with you. They might suggest or ask you certain intelligent questions, as is how would this work. So those are clues for you to understand that they want you to go in a different direction, or probably you're missing something, or they're asking you a question where if you can think aloud and think of a different scenario, in that scenario try to go through alternate designs. That should get you through the design of a warehouse. When you're thinking of alternate designs, if you're not able to think through, think about moving certain dimensions from stars, a big star, to a snowflake. A good example of this is a customer um, with with multiple addresses, could be snowflaked into customer, and address table can be separate. And you can link the customer to an customer address one to many, or there could be many other scenarios where you have um, an event, and the event has multiple dates. So the same event happens in multiple dates at multiple locations. So you can probably think about whether you can change the um, s- star to a snowflake kind of pattern. You can also replace multiple small dimensions with junk dimensions, and there are many other cases as well. But these are some examples where you can start thinking about alternate designs. The next thing we would do, I mean, the first step we would do is think about the entities and relationships, right? So let's think about what Tinder would need. So Tinder, somebody wants to get in, they would first want to set up a user profile. That means they go in, put in their email address, the phone number, the name, their age, and basic details. That constitutes the user profile. They would also answer a set of questions, I believe, which kind of help Tinder match with other people. This could involve like scenario based questions and how they would answer those. All those, I want to keep it like when it comes to the app, it probably is not going to be used all the time. That will probably be used to make predictions, or if the user wants to come in and edit the questions back, or look at how they answer the questions, they might want to come back. But typically, this is not going to be used every time a user like changes screen or logs in. Um, so I think the user profile is um, probably going to be much more widely used. Even though this is probably a one-to-one relationship, I think it's better to keep it separate. So we'll keep the extended profile separate um, for the application itself. Probably another part of storage you have to think about is photos. The photos could be stored as blob objects on database tables, um, but the most preferred approach would be to find a link to where the photos are stored, and then link it over. Just store the link on your extended on your user profile table. So the user profile table could have a link, a URL, and then that URL would actually point to an uh, object storage like S3, or um, like cloud storage in Google Cloud, and then that would actually point to your photo. So that could be a way of doing that. Another way I could another table you will definitely need is for the user to have potential matches. So after the user sets up his or her profile, uploads photos, answers questions, we would want to provide the user with potential matches. And this can be a separate table where the user logs in and scrolls through a list of photos, or swipes through a list of photos and gets through each potential match. And all those user potential matches are available in this table based on an algorithm that ran and got potential matches for user ID 1. And say if they have like 50 other matches that came up, so user ID 1 would be linked to uh, 2, and then user ID 1 will be linked to like user ID 7, and then all those links would be potential matches, and those can be stored in this table. That's my thought process. After they have potential matches, if the user goes ahead and does a left swipe or a right swipe, so those are all user actions that the user would perform. That would probably get stored in a separate table. I'm thinking we'll have another table for that called user actions. Um, and that so So the user profile, the extended user profile, and photos are all based on one user. The user potential matches, the user actions, these two are based on user to user link. So it would have both user one and user two, and the action user one performs on action on the user two, and if the user two performs another action on user one, then we would store it up um, in as another row, and each time somebody actually does a action, um, the performing action the user performing the action would be the first column. The user on which the action is being performed would be the second column, and we'll store that as one row. And when the second user actually performs a swipe on the first user, that will be stored another as another row. And after that, when somebody actually, if both of them actually do like, then they would be matched users. uh, for ease of use, I want to pull those out and store those matched users separately. This may not be needed because we could look up the user actions table and see if we have both uh, user one liking two and user two liking one, um, or if we need to like to make it quicker, we might calculate that action and store that in matched users, so that it's faster when the app runs. Um, but this the information that we need in matched users is available based on the user actions table. The user to user messaging would get activated whenever users are matched. So if user one is matched with user two, then user one is able to message user two. We're going to store um, the message itself as encrypted data. So um, we would not, I mean, the people who are handling the database may not be able to read the text that got passed between the user one and user two, but they'll have all the metadata information as to how many messages they sent, or um, information about when they sent the last message. So all that information would be present in the user to user message. So each time somebody does an action, we store it in these tables. But these are entities and relationships. These won't work for actually business inquiring, like how their business is doing, how well we are able to predict stuff. So what kind of questions would business ask? So that's my next point I want to cover. One of the things is, they might ask is, are the users are there any users without any final matches? So are we are we having users where they have no final matches, right? So if I go back to the previous slide, we can uh, we can actually look up the users from the user profile table, and then we can check if they are present in the matched users table. And if they're not, that would actually mean these users have no matched users. Yeah, this is probably something we can do with this operational table structure. But what if there are slightly tougher questions? Like, the next question they might ask is, are the users having sufficient number of potential matches? So this might mean not only the final matches, but also looking at final matches, potential matches. So you'll have to look up at the other table, potential matches, and see if we are able to provide a sufficient number of potential matches for all users that don't have a final match right now. And we could also look at patterns to see the users that don't have a final match, like how did they answer the questions, when are they logging in, when are they logging out, are they messaging people, are they liking more people, are they not liking much people. So we can probably look at their usage, how they use the apps, how they use the like functions, how they do that. And is there a pattern whether the users that are not having too many matches do they have certain patterns that match that? So that's a question that the business might ask. They could also ask which potential matches go on to be final matches. So this is kind of an intelligence as to understand if they are able to match, give very good suggestions for potential matches. So when user ID 1 is potentially matched with user ID 7, so the app would have run some artificial intelligence to understand how the answers questions have been answered, what location they live in, and many other metadata that the application has to come up with that potential match that 1 matches with 7. Um, but can we improve that? Like, is that whatever suggestion we made, is it actually working? So that's one question. And can we actually improve that suggestion going forward? So those are questions the business would like to ask as well. They would also like to ask how many users have not logged in for the last n days. Now, when I thought about this question, I thought, okay, so my diagram does not even cover logging in activity or device activity or anything like that. I could probably store the last login in the user profile itself, but it wouldn't actually cover any history. So I might need another table for this. But at this point, your interviewer might come back and say, okay, given the time constraints, we're gonna stick with this structure, and then we'll try to build a data warehouse for this, or they could go another route as well. So you just have to keep your ears open and see how the direction the interviewer wants this to be taken. Then they could also ask which of the users who have not logged in have a good chance of getting a match. So probably uh, another deep drill down that. They could also ask about the photos, checking the photos, building an AI algorithm to predict how the photos are, and based on that, could we predict like how soon they'll get a match, or will they get a match, or will they match better with somebody else? So using the photos to suggest AI. So here we do have the photos, and we do have those linked to the users. So I think even the current model would work to an extent, uh, but we don't want to like put any load on the application that's running. So we would, but we have all the information to actually do the answer this question. The next question that might come up is, can you use extended profile questions to analyze which questions answers that we ask in the extended profile can help the prediction better? So probably this is some way where if there are 10 questions, can we remove a couple, probably add more in certain subjects where we are better at predicting. So what are the topics where we have to add questions to make the potential matches better? So these are next kind of questions that we would come. So given all this, if you look at this, the next step we have to think about is, these are the business questions, but what are they measuring? So certain things are measures that will help us actually identify what the fact tables would be. So I tried to pull that out. I mean, given if we have a sales component, if we have a cash flow component, if we have a um, like quantity of like inventory, so those are like measures that are easily understandable. In this case, it was really difficult for me to come up with measures, but I kind of marked them down. So some of them are kind of measures. Like if you want to measure like how many users are without final matches, so we can do a count of the number of users that don't have final matches. It's a count that we can actually do. So that might mean it's a factless fact. But yeah, we could find all the users that don't have matches, and then we can count that out. Another thing we could do is like if you look at this, they're asking about number of potential matches, the second arrow, talks about number of potential matches. So that's also another count we could do. There's also going about potential matches. How many potential matches go on to be final matches? So that's another uh, example of the first two arrows coming together, then comparing those. And the last arrow would be the users that have not logged in the last n days. So that is probably something we can have as a, like, if we have all the times the user is logged in, we can probably find some patterns about when was the last time they logged in and how from the current day how long it has it been. We can get some intelligence around that. So that might be a measure, like, as to when the last login was. So that might be based on a log of the times they logged in, um, and keeping that, we could get it. The other things, I don't see other measures that are here, whether it's profile photos, how do you predict chance of match. So I don't see those as readily available measures. We might need to drill down deeper to actually get the information, but I don't see that we can store those as dimension tables and fact tables. So we'll start with facts, which are based on the measures. We need to measure the number of potential matches per user. We need to measure the number of final matches per user. Like, could we come up with some calculated user scores? I thought, would that be a fact? But that's not a fact. It's actually a um, it's a it's probably a dimension where we store a user score. It doesn't seem like it's a transaction that happens, or it's some action that happens. So that would not be actually a, even though it's a number, it's probably not a fact. And then we probably have to log in, find the login activity. So this was something I improved upon when I wrote the entity relationship diagram. When I thought about that, I didn't think about the login activity. But now that when I thought about the business questions, I came up with an additional measure that we could measure. So this could help answer questions as to when they log in, how they log in, and does that affect how they get matched up with other people. So the way I saw this is, probably there's one dimension table for users with all the user profile information, the photo link, the extended user profile. That would be a dimension. There'll probably be two facts. One with the user potential match, like all the user to user actions, whether it's like matched users, potential users, and user actions, whether they like something, dislike something. And then there would also be user to user messaging. So whenever somebody messages from A to B, we would need to store that as well as another fact. I did not cover the fact where, like, user, what you when does the user log in, when does the user log out, how long do they use it. That was not covered in this, but that could be another fact table as well. So the way I see it is, there are two facts tables, and they link to the user's dimension table, and the user dimension table has all the user profile fields, the extended profile fields, any calculated user fields, everything gets stored in the user dimension table. The user to user action table has a link between user id 1 and user id 2. And to keep it, like, when user id 7 is matched with user ID 1000. Um, I I wanted to make sure I'm not having two different rows, one for 7 to 1000, other for 1000 to 7. So I wanted to implement a logic in the application program that the data engineering pipeline that inserts records into this table, such that user ID 1 would always be lower than user ID 2. So in this case, 7 and 1000, 7 would be in user ID 1 and 1000 would be in user ID 2. When we're talking about an action between user ID 2 and user ID 7, user ID 2 would go in 1 and user ID 7 would go in user ID 2. So that was one additional thought process I put in. But essentially, user to user actions lists user ID 1, user ID 2, and then has a potential match flag. So if they actually um, if our AI algorithm says they are a potential match, then we'll insert a record into this, and we'll say the potential match is yes. At that point of time, the one-to-one like flag, that is whether user ID 1 likes user ID 2, would be null. User ID 2 likes user ID 1, which is the next column, would be null as well. The message flag would be null, and the last message timestamp would be null. So all this would be null. And then when one person, user ID 1, actually likes user ID 2, then the first flag, 1 to 2 like flag, would get populated as yes. If they dislike, it would be populated as no. And then if 2 also likes it, then both the flags would be populated as y. And if both are populated as y, we know that they are a final match. And then the message flag would turn on whenever somebody messages the other person, and the last message timestamp would get updated on this. So this is the way I saw it. And like one potential thing I did not notice at this point, I'll come back to that. But before that, there's another fact table with messages, which is just a user to user message. So user one, user two, what is the last time they sent the message. Probably I don't want to store the exact text of what the message is, but just some metadata around what time they sent it, what device they used to send it, or whatever other metadata we think we would need. We'll store all that in this table. We like in the Coming back to the user to user actions table, um, this this could this could potentially create multiple um updates for a fact table. And updating the fact table multiple times, especially in a large data set, is going to be potentially disastrous. So we like to keep all the fact tables as insert only, and if we are designing it any differently, that could cause some kind of performance issues when you do an update, because like the database has to figure out where the record is, then update that record, and whenever the update happens, it might trigger other actions like index update, or if it's a clustered table, it might even rewrite certain like locations where this is, so that the update might be very costly. So we should avoid updates. So I think I missed the version here. So I came back there and added a version um, at the bottom. So let's check if we are able to answer all our questions based on this. So one of our questions would be, would are there any users uh, without any final matches? So all we'll have to do is check the user dimension, see if the user is present in user ID 1 or in user ID 2 with um, both the 1 to 2 like flag and 2 to 1 like flag as y. If both of them are y, and if the user ID is present in either 1 or 2 in the fact table, um, then those user IDs have a match. And if we find any user IDs in dimension table which don't have this criteria, then those are the user IDs that we have to figure out that they have no final matches. So to find potential matches, we can do a similar query. Um, so these kind of queries could essentially be done. For the fourth arrow about the last login, um, like I don't have a scenario where that is being taken care. I think adding another fact table would be the best approach for that. We have all the information about when a person logged in, when a person logged out, and that the grain for that would just be one user ID at any time they log in, the what time they logged in, and what action they did, whether it's a login or a log out. So all those things would be stored in like a user login action dimension fact. So it'll be a fact which says user login actions. Um, so that could be another fact table as well. So that could help answer those questions. This is my thought process. Obviously, we can do this better, but given the time constraints, this is what I would come up with in an interview. If you have any thought process on how to do this better, please let me know in the comments below.